Dear students, let us continue the study of the paper of forensic chemistry and explosive, and in this particular module we shall be studying about the trap cases, the bribery, and how the evidence is collected that whether the bribery has been taken place or not. So, if we look at the learning outcomes of this module, dear students, we shall be able to know what does the term bribery actually mean, what is trap related cases, and you shall be able to be familiar about the legal definition and penal provisions of bribery. Then the dice are having a very significant role in detecting bribery and the trap cases. So, you shall be made familiar about the various dyes which are used to detect these cases. We shall try to see what are the various chemicals which are used in these trap cases. And when we talk about these chemicals, we shall be focusing on phenolphthalein and anthracene, and you shall be able to make yourself familiar about the chemical and physical properties of these dyes. You shall be able to also learn how to examine a trap case and how the forensic analysis of the trap related cases is done in the forensic labs. And when obviously when you are dealing with the forensic analysis, then the sample collection becomes very important thing. That is how the sample collection has to be done from the crime scene and brought to the lab. So, let us begin with this module, dear students. Bribery, as you are already familiar, but we will go into more technical definition. Bribery constitutes any act of giving gift or money of dishonest nature for altering its recipient's behavior. Bribery is an offence and may be defined as the offering, giving or receiving or soliciting of any valuable item for altering the conduct any person bearing a legal or public duty. Gifting any valuable item or money which is of open nature and is available to all on an equivalent basis without any dishonest intention is not considered as bribery. So, you should be able to make this difference when the gifting is bribery and when this sort of gifting or acceptance is considered to be a bribery. Similarly, offering partial or full refund or a discount to the purchases of the same type, quantity and quality or service or product is not considered to be bribery, but actually it is a legal rebate, and it is absolutely legal for an employee of electricity department to accept a rebate on electricity. So, this is just an example. Thus, bribe could be defined as a gift offered with an intention to alter to conduct of the recipient. It may be anything from goods, money, property, object of value, privilege, preferment, advantage, emolument, or merely an undertaking or promise to influence the vote, action, or influence any person of official capacity. In the trap related cases, generally if we talk about the chemistry, because in this particular paper we are focusing on the chemistry and how chemistry is able to help all these trap cases. In the trap related cases, generally anthracene or phenolphthalein are the two chemicals which are used, and they are used during the anti-corruption operation as proof of acceptance of bribe. And how it is done? Let us try to understand. Phenolphthalein powder is nothing but it is a chemical which is white colored smooth powder, and it is spread on the currency notes and the other objects which are likely to come in contact with the hands of the perpetrator, resulting in its transfer. And if you recall, you are already aware, this is based on the Locard's principle of exchange. The hands are washed with a colorless solution of some basic material like sodium carbonate or lime as lime water. So, when phenolphthalein comes in actually basic medium, aqueous basic medium, it immediately converts its color from colorless white to pink color. So, when the hands of that person who has actually taken those notes or the other material are washed with a basic mild dilute basic solution, what will happen is it will turn pink. And this confirms that the touching of those currency notes which have transferred the phenolphthalein to the hands. And depending upon the quantity of phenolphthalein, evidences are then sent to the forensic laboratories along with other evidences for analysis. So, dear students, it's a very simple test which can be done. You have to simply spread the phenolphthalein powder on the notes or other such articles, and if that person has really touched, then the powder is, even if it is in very minute quantity, will be transferred to his or her hands, and the moment those hands are washed with dilute basic solution, they will turn pink. Another thing which you should keep in mind is the phenolphthalein color fades gradually and can become colorless at the time of trial in the court. So, this creates unnecessary doubt and investigating officer is put in an awkward position. However, this can be explained by the scientists that the phenolphthalein color fades due to the formation of 2,4-hydroxybenzoyl benzoic acid and phenol under basic condition, that is further hydrolysis is taking place and it is taken. And to avoid this, what you can do is, with now ICT coming into place, you can easily click the photograph, you can take the snapshot, or you can even do the videographing when you are performing this test. So, this will be a better evidence, yes, you had conducted this test and at that particular time the color was there. To avoid this shortcoming of phenolphthalein, scientists have been using anthracene powder, which is another chemical which can be used for this purpose, that is for trapping cases, as it does not have such issue of color fading, and it also has advantage due to its fluorescence property. So, what is done here is the hands or clothes of the suspect can be immediately examined under the UV light or violet or blue fluorescence which is produced there, and it can be clearly perceived. And this proves again the direct contact of the suspect with those currency notes on which the anthracene powder was coated. Pure anthracene shows blue fluorescence, but impure anthracene can show yellow with green fluorescence also due to the presence of some other chemicals in it like tetracene, naphtacene, etc. But yes, any kind of fluorescence will obviously mean that that particular powder has been touched and it will prove the case. The hands or objects can be cleaned after you have performed the experiment with the ethyl alcohol or ethanol for the forensic examination. In the lab, it is not that you will be carrying these powder on your hand. And another thing, when you are doing such, you should use the gloves. But if by chance then also some powder has been left on your hand or other part of the body, you can get rid of this by ethanol. Another thing, generally in the trap cases, phenolphthalein or anthracene are both widely used by various investigating agencies like anti-corruption branch of CBI and vigilance department. So with this background, dear students, let us go into more details of the trap cases and how these chemicals are used for the investigation at the forensic lab or otherwise, and how they prove very useful that yes, bribery has taken place, and that we will be doing with the help of graphics and visuals.
Provisions under IPC. Section 171B of IPC defines bribery, and Section 171E deals with the punishment of bribery. Now, Section 171B, that is bribery. Whoever gives a gratification to any person with the object of inducing him or any other person to exercise any electoral or of rewarding any person for having exercised any such right, or accepts either for himself or for any other person any gratification as a reward for exercising any such right, or for inducing or attempting to induce any other person to exercise any such right, commits the offense of bribery, provided that a declaration of public policy or a promise of public action shall not be an offense under this section. A person who offers or agrees to give, or offers or attempts to procure a gratification shall be deemed to give a gratification. A person who obtains or agrees to accept or attempts to obtain a gratification shall be deemed to accept a gratification, and a person who accepts a gratification as a motive for doing what he does not intend to do, or as a reward for doing what he has not done, shall be deemed to have accepted the gratification as a reward. Section 171E. Punishment for bribery. Whoever commits the offense of bribery shall be punished with imprisonment of either description for a term which may extend to 1 year, or with fine, or with both, provided that bribery by treating shall be punished with fine only. Explanation. Treating may include that form of bribery in which gratification consists in entertainment, drink, food, or provision. Classification of offense: bailable, non-cognizable, triable by magistrate of the first class, non-compoundable. Next, we will study about detective dyes. Detective dyes are the chemicals which are generally used in catching the bribers red-handed. In trap-related cases, although number of techniques is used using different chemicals like starch powder, fluorescent dyes, phenolphthalein powders, anthracene powder, etc. But phenolphthalein powder is still most popular one in India. Generally, phenolphthalein or anthracene are used during anti-corruption operation as proof of acceptance of bribe. Next, we move on to chemistry of phenolphthalein. Phenolphthalein is an organic compound which belongs to the family phthalene having chemical formula C20H14O4. It is a white, smooth textured powder that is widely employed as a laxative and as an acid-base indicator. The property and its information for phenolphthalein has been indicated in the following table. Molecular formula C20H14O4. Molar mass 318.32 grams per mole. Specific gravity 1.277 at 32 degrees Celsius. Melting point 260 degrees Celsius. Log K 2.41. Vapor pressure 6.7 into 10 to the power minus 13 mmHg at 25 degrees Celsius. Dissociation constant 9.7 at 25 degrees Celsius. Density 1.277 grams per centimeter cube at 32 degrees Celsius. Solubility in water insoluble. Solubility in other solvents insoluble in benzene, very soluble in ethanol and ether, slightly soluble in DMSO. The molecule has four different forms, each giving a specific color based on the pH of the solution. It turns colorless in solutions of acidic nature and basic solution it turns pink. As the value pH varies, the color of the phenolphthalein solution also varies. In strongly acidic solutions, pH at near zero, it appears orange color. At pH range between 0 to 8.2, it appears colorless. However, it appears fuchsia between a pH range of 8.2 and 12. With a pH value of above 12, it will again become colorless, like that of acidic or neutral solutions. Its unionized molecules are colorless, and after ionization, it gives colorless H plus and pink colored phenolphthalein ions. The molecule has following four forms. Hence, the species with their structure, pH, conditions, color, and image have been mentioned in this table. Next, we will study about the chemistry of anthracene. Anthracene is known to be a polycyclic aromatic hydrocarbon with three benzene rings fused together. It is a constituent of coal tar and used in the manufacturing of the red dye alizarin and other dyes. Anthracene is colorless but shows blue fluorescence under ultraviolet light. The property for anthracene and the information including the molecular formula, molar mass, boiling point, melting point, density, solubility in water, and solubility in other solvents has been shown in this table. Chemistry of fluorescence. Anthracene photodimerizes under ultraviolet light. The dimer, called para-anthracene or dianthracene, is linked by a pair of new C single bond C, the result of the cycloaddition. It reverts to anthracene under UV irradiation below 300 nanometers or thermally. These properties are the grounds of potential applications of anthracene. Substituted anthracene derivatives behave in a similar manner. Presence of oxygen affects reaction. Next, we will move on to forensic analysis. First is tests for phenolphthalein. pH test. Observe the pH of the solution. Exhibit with the pH paper. More than pH 9, that is, pH range from 8.3 to 10 with pink or red color shows the positive test for the presence of phenolphthalein. Next is acid-alkali test. On addition of few drops of dilute hydrochloric acid, pink color disappears. Now add few drops of dilute solution of sodium hydroxide in water. The pink color reappears. Appearing and disappearing of pink color indicates the positive test for the presence of phenolphthalein. Thin layer chromatography or TLC. The various standard conditions are stationary phase, TLC plate coated with silica gel G, mobile phase, chloroform and acetone in the ratio of 80:20, developing reagent, spray with dilute sodium hydroxide solution and then acetabide potassium permanganate solution after visualization observed under UV light for fluorescence. Next, we move on to instrumental analysis. Take a small portion from existing solution, filter it, and then analyze absorbance value by using spectrophotometer in appropriate dilution using a standard solution of phenolphthalein in base. The solution so obtained is pink in color and gives the lambda max in the range of 550 to 555 nanometers. Aqueous solution of sodium carbonate is used as blank solution for the experiment. Other instrumental tools like HPLC, FTIR, and GCMS are also being used for the detection of phenolphthalein. Next are the tests for anthracene. First is UV test. Under ultraviolet light, anthracene shows violet or blue or green color fluorescence. Thin layer chromatography or TLC with its standard conditions are stationary phase silica gel G, mobile phase heptane is to hexane. After visualization, observe the plate under UV light for fluorescence. Gas liquid chromatography or GLC with their standard conditions are detector, flame ionization, column, SS column 1 by 8 inches diameter, 2-meter length, packing 10% Se, 30, 80 by 100 chromosome WHP, carrier gas, nitrogen, flow rate 25 milliliters per minute, injector temperature 250 degrees Celsius. Column temperature 220 degrees Celsius isothermal. Detector temperature 250 degrees Celsius. Sample preparation in ethanol. Next, we move on to sample collection. Generally, in trap cases, anthracene and phenolphthalein are used by various investigating agencies like Anti-Corruption Branch of CBI and Vigilance Department. Now, under sample collection, first we will study in case of phenolphthalein. Phenolphthalein powder is generally applied in trace amounts on the currency notes and other objects that are probable to come in contact with the hands of the perpetrator, resulting in its transfer. The hands are washed with a colorless sodium carbonate solution or sometimes with lime water, which immediately turns to pink color, immediately confirming the contact with the currency notes. Pink to deep red color is developed based on the amount of phenolphthalein involved. These washings are collected, packed, and sent to the FSLs for analysis, along with other required relevant materials. It gradually fades and in some cases becomes colorless at the time of trial. This creates unnecessary doubt and investigating officer is put in an unexplainable position. However, this fading can be explained on the basis of its breaking down into 2,4-hydroxy benzoyl benzoic acid and phenol in an alkaline medium. Next, we'll study about the sample collection in case of anthracene. Anthracene powder is now rarely used in trap cases, but its advantage is that it does not pose any problem of color fading and of course its fluorescence property. The hands or clothes of the suspect can be immediately examined under ultraviolet light, violet or blue fluorescence, and it can be clearly perceived. This proves direct contact of the suspect with currency notes. Pure anthracene shows blue fluorescence, but in its impure form due to presence of tetracene, naphthalene, etc., shows greenish yellow fluorescence. The hands or object can be washed with ethanol for the forensic examination.
Summary. So dear students, let us summarize what we have learnt in this module. We have learnt that bribery, if we look at the proper definition, constitutes any act of giving gift or money of dishonest nature for altering its recipient's behavior. In the trap related cases, we have studied that normally the two very common chemicals, phenolphthalein or anthracene powders, are used. Phenolphthalein or anthracene powders are both white or pale yellow colored powders in nature, and phenolphthalein or anthracene, if we see how they are useful, phenolphthalein when treated with basic solution gives pink color, and anthracene with UV light will be giving you green to blue fluorescence. And it is used to trap corrupt person and catch them red-handed in bribery cases. It is very commonly used by various investigating agencies like Anti-Corruption Branch, that is CBI, and Vigilance Department. Section 171B in IPC, which defines bribery, and section 171E, which deals with the punishment of bribery, you should remember. Phenolphthalein, we have studied the structure also in detail, that it is an organic compound which belongs to the family of phthalene, and it has molecular formula C20H14O4. It is a white smooth textured powder that is having reaction in different in acid and base medium. So, it is also used as the acid base indicator, and in basic medium it will change its colors from white to pink, and that is what is being utilized in this. On the other hand, anthracene, which is C14H10, it is a solid aromatic hydrocarbon having 3 fused benzene rings. It is also colorless, but sometimes it may be pale yellow color, and it shows blue fluorescence under the UV light. We also studied that a number of tests and instrumental techniques are applied for the analysis of such transferred phenolphthalein and anthracene. The preliminary screenings of anthracene or phenolphthalein powder are done by color test and pH test, and the confirmatory and instrumental tests are done further by TLC and UV spectroscopy. Thank you.